Yesterday, when we stopped our episode 27, we told about developments this portion. Today, in episode 28, I would like to say the remaining portion of remaining development of this development. So, if you haven't seen episode 27, you won't be able to understand. So, go to my episode 27, afterwards come to episode 28. We were finding out a great development of one cone. Yesterday I had indicated this all, so I don't describe this all. It's previous day also I had described this all, so I don't say more about it. You have to just revise and come to today's episode 28. But our first day related with this development, we told about one cone. Its diameter should be like this and its vertical height should be like this. Its vertical height is too much, so it can't be made from a single plate. In shops, we won't get this much lengthy, widthy plates. So we will have to divide it with 2000 or 1500 or 2500 or 3000 something. For teaching you, now I divided this 30,000 height cone into so many parts. Each parts had inclined height of 2000. First, yesterday and its previous episodes, we were trying to find out the development of bottom portion. Means it starts from here to here and to here and to here. This cones, not this cones or this cone. This cones development we were making. So you have to just study about my yesterday's or previous days episodes and come to today's episode. Okay. Yesterday and its previous days I have told about this, and I have told about this. I have told about this. I have told about this. When I told about this page, I told you previously this cones. It means I had indicated you some minutes ago. It is having vertical height of 30,000 mm and its diameter is 2088. Its development can be made in two ways. One way is like this, means this is development from here to here and to here and to here. Finally it reaches here. This is development. Its end to end length we have to find out. Afterwards, this line has to be divided equally and perpendicular lines have to be made to bottom side. Then each lines will have different lengths. This different lengths have to be found out. If we find out these different lengths, we can make this radius. Why do we make this kind of radius? Because its radius we found out yesterday, it was so lengthy radius, 59,019.8. It is impossible for all of us to make that kind of one compass from here to here. Very difficult to make a compass. Sometimes we may have made, even if it is so, it won't have accuracy. So we have to follow this kind of method. That is one method. The second method is, this is development. I don't describe more because I have told you yesterday and its previous days. Development is this one. After, for making cone, we have to make a development. This is development. It starts from here to here, and then here, and then it comes here. Finally, it reaches here. This development's first method is like this, and the second method is corner to corner, end to end. We have to find out using trigonometrical calculations. And center portion we have to find out. From center to curved portions center, we have to make one line and we have to find out this distance. This line will reach to the center of these two lines. These two lines means this is one line and this the second line. This one will reach here and this one will reach here, like this. This one will reach here and this one will reach here. And this portion, I have indicated it here. This portion also will reach here. If we make another line from here, that line also will reach here. In development, we will be finding out this kind of so many lines from different areas. Those all lines will be reaching in origin of center. Okay. So that is one, the second method. First method is this one. Second method is this one. Corner to corner, we have to find out. Then its center to curved portion center, we have to find out using trigonometrical calculations. If you find out this one, we can make just straight line only. But we know this is not a straight line, it is a curved line. For that purpose, again we have to find out curved distance from straight line. For that purpose, this corner to this corner, one more line we have to make. Its center we have to take, however we have taken center of this one. From this center we have to make one perpendicular line to the curved portion. Curved portion we will find out using trigonometry. Also remember, this curved, for getting one line we have to use this. This is a perpendicular line from here to here. It also will be reaching in the center of radius. I told you some minutes ago that line also will be reaching center. If you take one line from here, it also will be reaching center. If you take one line from this area, it also will be reaching center. That kind of corners have to be made, triangles have to be made and find out. Okay, then find out, we found out this one. Afterwards we found out another one. If we find out this one, we will get one same measurement will be here also. When we found out this measurement, we got to, it was useful for one place. But when we got this measurement, it was useful for two places, here and here. Then we got some more accuracy. But we know this is a curved portion. Again we have to make line. It has been indicated in, again we have to make line. Its center portion we have to find out. Then we will get 1-2 portion here, again 1-2 portion here, again 1-2 portion here, again 1-2 portion here. Means 8 portions, 8 places we can find out measurements. First we got one measurement, it was useful for only one place. Again we made one more measurement, but it was useful for 2 places. Again we made one more line measurement, it was useful for 4 places. Again if we make, it will be useful for 8. Again if we do it, it will be useful for 16. Like that, so many places measurements we can find out. Okay, yesterday when we did this all, yesterday I had told you this all, so I don't describe it. Up to here I told you. before this, we found out this measurement 22.5. I will just show it in development. This is our development. In this development is starts from here to here and to here and to here and it ends here. Okay. Its development, so first measurement we got 89.9 yesterday. I don't describe more. Again we made one more straight line and its center we have taken and we have made one perpendicular line from this line. Its measurement 22.5. This was useful for here also. And once again I repeat, this line will be, this perpendicular line will be reaching in the center of the radius, center of the round. Again we made one more straight line and we have to find out this measurement. This is our aim. We have to find out this measurement and we can just check. Okay, we were trying to find out that measurement. Okay, we shall try to find out that measurement. Okay, so yesterday we took this kind of one triangle. This triangle's total degree was, 1.5707. Total degree was 1.5707. But we are making one straight line and its center to perpendicular distance to the curved portion's center. For that purpose, this 1.5707 degree has to be divided to 2 by, we have to get one 90 degree triangle. So what will we do? In next diagram we shall check. Total degree is 1.5707. This is into 90 degree. This is into 90 degree. Because these two lines are starting from radius's one portion and it reaches to center of the round. This is also same. So automatically it won't be 90 degree. It won't be 90 degree. We have to find out 90 degree. Otherwise, we can't use trigonometrical calculations. For that purpose, for getting 90 degree, we shall make a line from here to here. If we make a line from here to here, its center portion will become 90 degree. This will be 90 degree. This one also will be 90 degree. So, for avoiding confusion, I take this triangle only. From here to here, and to here, and to here, and its related curved portion, this much. I just make details of this triangle and this curved portion here. Listen, from here to here, here to here is here, and the curved portion is here, and from here to here, that is also here. In between one line is there, that also I have indicated. Why did I draw this one? Avoid confusion. Okay, if we know, already we know its radius is 59,019.8. Yesterday and its previous days we studied about it. And we got its degrees 0.7853. How did we get it? Total degrees 1 point something. We divided total degrees 1.5707. We divided it with 2. Then we got 0.7853 is one half portion and 0.7853 is another half portion. This triangle I just drew to here 0.7853. Using these two measurements, we can find out this measurement from here to here. Earlier we were finding out like that. If we get this measurement from here to here, already we will get this measurement. Then from straight line, how many far away this curved line comes, we can find out. Okay. Yesterday, for finding out these kind of measurements, we were using cos theta. There are 3 formulas in trigonometry. I don't describe those all because in so many episodes I have told you about it. One is sin theta, another one is cos theta, and third one is tan theta. If you have these base formulas, you can do most of the trigonometrical calculations, most of the fabrication calculations, because it is the base of trigonometry. It may be the base of fabrication also. Okay. For finding out sin theta, we have to use opposite side divided by hypotenuse. Opposite side OS divided by H. For finding out cos theta, we have to use the formula adjacent side divided by hypotenuse. Adjacent side AS divided by H. For finding out tan theta, we have to use the formula opposite side divided by adjacent side. Opposite side is OS and adjacent side is AS. Okay. In this 3, which one will be matched here? We can use cos theta. If we use the formula cos theta, we can find out measurement from here to here. Because in cos theta, theta is here, degree is here, 0.7853, and that cos theta I have written here 0.7853, and in equation adjacent side is there. Adjacent side is from here to here, that is here. But we have to find out in one equation if there is one measurement, we can find out that measurement. Other measurements have to be in that equation. That's only. In this equation, H is also here, which is hypotenuse. You know about it. Hypotenuse is the opposite side of 90 degree. Hypotenuse will be the lengthiest side of one triangle. Okay. Then this is H, 59,819.8. So cos theta is adjacent side divided by this much of measurement. So we have to find out adjacent side. For that purpose, we have to keep adjacent side here, and we have to take this 59,819.8 to left side of is equal to. Then I have told you, so I don't describe. If we take this bottom measurements to there, it will reach in top side. If it has been divided, when we take it to left side, it will be multiplied. Both has happened. What is this measurement? Use your calculator and find out. You will get this measurement. You shouldn't see as a man who is watching cinema. It isn't a cinema, it is a calculation, it is related with the fabrication. We are studying fabrication. We are studying fabrication's bending. We are studying fabrication's rolling. So, you have to use calculator. You have to use A4 size notebook. You have to use instrument box. It's all things should be with you. You have to draw it. So, just keep my video in pause and find out this measurement. Multiply this two. Afterwards again see my video. Okay. Cos theta is equal to cos 0.7853 into cos 0.7853 cos 0.7853 into cos 0.7853 into 59,819.8 819.8 is equal to, we get 59 is equal to we got 59,814 59,814.2. This measurement from here to here we got 59,814.2. What is 59,814.2? That is the measurement from here to here. If we have got this measurement, we will get this measurement. How will we be getting this measurement? Because this is radius. This is radius. This is radius. This radius is 59,819.8. Total radius is 59,819.8. We have now got this measurement also from here to here. Then total radius minus this measurement from here to here will be this measurement 59,819.8 minus 59,814.2. You just subtract it in your calculator. 59,819.8, 0.7853 degree. Now we got 59,814.2, 59,814.2. If you decrease this 59,814.2 from radius, we will get this measurement, that is 5.6. Now we have got 5.6. So in our development, we have got one more measurement. First 5.6, now we have got. This is our development from here to here and to here and to here, and it ends here. In this development, we have got 5.6 just now. First we got this measurement, it was useful for only one places, and second we got this measurement, it was useful for here and here. Again we made and got this measurement 5.6, it was useful for here and to here. Again it's total opposite side, here and here. 4 places it was useful. First it was useful for one place, second it was useful for 2 places, third it was useful for 4 places. Again for accuracy we have to make one straight line from here to the corner, and its center has to be taken, and one perpendicular line has to be drawn to outside for finding out how far radius line, round line is coming. Okay, we shall come to the next calculation. So now we have got 5.6. Okay, just think development. Our development is from here to here and to here and to here, and it ends here. Okay, already we have this radius from here to here is 59,819.8. First, when we made a straight line and we tried to find out this, we got the measurement 89.9. Again we made a straight line from here to here, its center we took and marked one perpendicular from the center to the center of the radius. Then we got 22.5. Again we made one line from here to here, that I have been indicating here. I don't take full development, I have been taking the small part of this triangle only, from here to here, from here to here, and 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 from here to here. Small triangle I have taken for avoiding confusion. So just think about this line from here to here, that is this line. That now we got 5.6. Again we have to make one more line from here to here. Its center has to be taken. Perpendicular line has to be drawn from its center to outside. We will find out one more. For that purpose, I avoid this portion, and I take this portion only from here to here, here to here, and from 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 here to here. So 59,819.8. Once again I have written here. This degree is from here to here is 0.7853. That is the degree from here to here, because it's half portion I have written. But we have to find out its center distance. For that purpose, 0.7853 has to be divided into 2, and it's a small triangle. Once again I have drawn here. This 59,819.8 line I have drawn here. This 0.7853 is half portion, that is 0.3927 degree has been drawn here. And the line from here to here I have drawn here. And the line from here to here I have drawn here. And the line from here to here also I have drawn here. Using this degree and this measurement, find out this side. I don't help you now. You use your calculator and find out. For that purpose, you have to use the formula cos theta. Just go to cos theta formula. Cos theta is adjacent side by hypotenuse. Cos theta is now degree is 0.3927. Now degree is 0.3927. So we have to write cos theta, instead of cos theta we have to write cos 0.3927, and adjacent side we have to find out, so we have to write their adjacent side, and divided by hypotenuse was earlier hypotenuse 59,819.8, 59,819.8, that has to be written 59,819.8. okay, we have written it. We have to find out adjacent side, so we have to take this 59,819.2 left side. It will be multiplied and it will be reaching there. I am not describing, it has been told in my previous episodes. So use your calculator and find out cos 0.03927 into 59,819.8. It will be this measurement. What is this measurement? 59,818.4 means the measurement from here to here only. Here to here is 59,818.4. I have written it here. 59,818.4. That is the measurement from this portion to this portion. Okay, then what will be this measurement? You know, from this measurement means radius. From radius, this measurement has to be decreased. 59,818.4 has to be decreased. Then we will get 1.4. 59,818.4 is here. Same triangle I have drawn here. But I have subtracted and I have written this measurement. That is the only difference. Okay, now we got one more measurement. First, in our development, starts from here to here and to here and to here, and finally it reaches here. In that measurement, first we made one line from corner to corner, its center to the center of round portion. We have found out its projection is 89.9. Again we made a line, then its projection was 2.5. It was useful for two places. Again we made straight line. We could find out its projected line, it is 5.6. Again we made straight line and we could find out projected portion, it is 1.4. It is 1.4. Just check this development. Can you find out any speciality in this measurement? 89.9 and 22.5 and 5.6, 1.4. You have to find out. You have to be an inventor. You have to be a scientist. You shouldn't be an ordinary fabricator. If you love iron, steel, you have to be the fabricator of fabricators. Fabricator of fabricators is called engineer, and engineer has to be the engineer of engineers. If you are the engineer of engineers, you will become a inventor. You will become a scientist. Then also you shouldn't stop your studies. You have to be the scientist of scientists. Now I am asking you to invent one thing. What is the speciality of these measurements? 1 minute, keep it. Not 1 minute. 5 minutes. Keep it in your. Keep this video in pause and find out how many times smaller is this one, and how many times smaller is this one, and how many times smaller is this one, or how many times this measurement is bigger than this one, or how many times this measurement is bigger than this one, or how many times this measurement is bigger than this one. You can recognize this measurements 4 times big is this one. This measurements 4 times big is this one. This measurements 4 times big is this one. If it is so, this measurements we haven't find out. We haven't found out this measurement. This measurements 4 times big will be like this one. So no need to go to scientific calculations, trigonometrical calculations, sin theta, cos theta, tan theta. Divide this 1.4 divided by 4, then you will get 0.35. This measurement will be the measurement of here. This measurement will be applicable in 32 portions, because it was applicable in one portion, it was applicable in 2 portions, it was applicable in 4 portions, it was applicable in 8 portions. This is applicable in 16 portions. Sorry, I told 13 portions. No, it is applicable in 16 portions. So our development finishes here. 0.3, after 0.35 again we can divide it with 4, but no need. This 0.35 is very negligible. When we make one cone with 30,000 mm length and 2088 diameter, this 0.35 is negligible. That is nothing. If we avoid this one also, we can using one Spanish curve, we can make a line, curved line. Okay, so I am just suggesting you, don't try to find out the fourth portion of 0.35. So our development finishes here. This measurement, this measurement, this measurement, this measurement. Finally, we got this measurement also here. So in development, I am indicating that is 0.35 also. In our development, now I have indicated this 0.35 also. First, we found out 88.9, next 22.5 and 5.6, then 1.4, then 0.35. Okay, our developments approximate 50% finishes here. As a homework, I tell you, same type of measurement we have to find out here also. For that purpose, one line has to be made here. Its center portion has to be found out. However, we have used scientific calculations, sin theta, cos theta, tan theta, and a square plus b square plus c square also may have used just to find out this projected length. Again, make one line. Its center portion to perpendicular projected length has to be found out. You just find out it. It is a homework for you. Then this development will be finished. Now approximately 50% finished, more than 50% finished, because this measurement we have got, this measurement also we have already got. Only this measurement has to be got. So in our development, actually we were trying to find out the development of a cone which is having a vertical height of 30,000 and a diameter of 2088. Diameter of 2088 and vertical height of 30,000. In its earlier I have told you, this kind of one single plate we won't get in shops. So we have to divide this kind of so many parts, 2000 inclined length type, so many parts we have to take. Now I divided it with 2000. If it is possible, you can make, if you get 3000 inclined length, you can use 3000. If you don't get 2000, then you will have to go to 1800 or 1500. But if you decrease this length, so many welding joints will come. That is not good. So try to lengthen this measurement 2000. That kind of plates have to be purchased from shop. Okay, now we got this dias development there, and as a homework I gave you the development. I asked you to find out the development of this portion. If you find out this portion, this portion's development will be finished. Afterwards, you have to go to same type of calculations you have to do, and this second cone, this is bottom cone, it is second cone, it's development you have to find out. Then this one, if you studied this all, very easily you can do this all. Within minutes you will find out. It will have more accuracy. Okay, I think you have studied this all. Once again, I just show these all pictures from the starting to end, and I just conclude this one. From here, today we started our class. It is Degree Calculators English episode 28. It is number 289th video. For finding out my 289 videos, just do Joseph Jude Kanatte Nicolas in YouTube searching title. If you have got any plus points, if you have got one more knowledge in your fabrication field, when you checked my today's video, just share it, just subscribe it. If you haven't got any kind of knowledge from this video or my earlier videos, please don't share it and don't subscribe it. Okay.